Hi everyone, welcome back to the channel, and today solve Leetcode daily challenge problem number 1457, pseudo-palindromic paths in a binary tree. So it is tagged as a medium problem and we'll be using DFS to solve this one. So we'll first go through the problem statement, we'll understand that, and after that we'll check out the approach which we're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that given a binary tree where node values are digit from 1 to 9, okay, a path is a path in the binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is palindrome. Okay, so basically we will be given a binary tree which will have numbers ranging from 1 to 9, and we have to find out pseudo palindromes in the path of it. Pseudo palindromes are basically uh, the pair which can result in a palindrome. Okay, at least one permutation of that pair or that group or that of the nodes in the path can result in a palindrome. Return the number of pseudo palindromic paths going from root node to leaf node. Okay, so basically we have to check for the complete path starting with the root node and ending at a leaf node. Okay, and we have to return the number of pseudo palindromic path in the tree. For example, in this image you can see we have two palindromic paths, pseudo palindromic paths. First one is marked in red, second one is marked in green. Why? You can make 3 to 3 with this group, right? With these elements, these node values, and with these node values you can make 1 to 1, right? So that's why the answer of this example is 2. So what we will be doing is we'll be using a DFS approach to solve this problem, and we will traverse one complete path first, then we'll trace back to the last node. We'll check if that have a right node or not. If yes, like we will traverse this and so on so forth. So let's check out the approach. Okay, so I have taken the same example from the problem statement, and I would like to first start with one of the properties of a palindrome. So there can be at most one element with odd number of occurrences. For example, it can be like 3 2 3 or 3 2 2 3, like, right? You cannot create like these two are palindromes, but you cannot write this. Okay, let's say this. Okay, this is not a palindrome. Why? Because if you read from both the direction, it is different. So this is one of the property that the number of elements with odd number of occurrences can it max be one. Okay, so this will be leveraging this property of palindrome, and to do that, what we'll be doing is we will uh, we will go through each of the paths. Okay, and we will be counting out the odd number of occurrences of element or the number of occurrences for element. Okay, and in the path, for example, in this path, okay, we started with the root node. Okay, then we said I'll create a temporary dictionary over here. Okay, let's use this one only. I'm talking about this path for now. Okay, in this path we started with 2, we marked it as 1. Okay, now we encountered 3, we added that element and marked the number of occurrence as 1, or the frequency of that as 1. Now next, again when we'll move, we see 3 again, so we will update to 2. Okay, so if you see how many elements in this hash has a single or has a odd number of occurrences or odd frequency, this is 1, right? So let's keep it 1 here. Okay, now we will trace back. Okay, and I will use the same dictionary which we have used over here, because it will resemble the code which we are going to use. Now the path which we are going to follow is this one. Okay, 2 3 1, we encountered 2, we wrote 1. By the way, like we had this one, right? We tracked back to the previous node. Then what we'll do, we will again update the element to or the number of occurrence of 3 to 1, right? Now we are following this path, 231. Okay, we already know that we have we have the number of occurrences list point. We checked for the next element, we had 1, and this is also 1. So number of elements with odd number of occurrences or odd frequency is 3. Okay, so this doesn't satisfy the property, so this path is not possible. This path is possible. Why? Because this satisfies the condition. Now next path is which one? Okay, we again we will do the trace back again, and 1 will become 0. We will make this 0. 3, like we will be at this point, then we will again trace back, as we have already traversed both the child node of this node. So we will again trace back, and this 3 will also become 0. We only have 2 in the hash map. The only path left is this one. So we move to 1. We already had 1. We will update the value of it as 1. Again, there is one child node to this node. We will check out that one as well, and that was also 1. So we will update the value to 2. Now how many elements have odd number of occurrence or odd frequency? This is 1 again, right? So what we can say, this path is also a valid pseudo-palindromic sequence. Okay, so this is what exactly we will be implementing in the solution. So let's check out the code for the same. Okay, as you can see what we are doing over here, I have defined a dictionary with default tick, because I don't want to get an key error with any of the new key, and I didn't want to use the get method for that. So what I have done, I have used default tick, and we are taking integer values as the default value of any of the key. And there is this variable odd, which we'll be using to calculate number of odd occurrences of elements in the path. Okay, from root to leaf node. Now we have defined this recursive function called DFS, and this is the base condition. If not node, return 0. So if the node is not valid, okay, we will just simply return 0. And this line is added because I wanted to make this this element accessible within the recursive function as well. Otherwise, in many cases in assigning it or updating the values, I was getting some error. Okay, so that's why we have added this line of code. Next is what we are doing. We are updating our hash map with the number of occurrence of the node value. Okay, so the value of the current value, the frequency of the current value will be incremented with 1. Okay, now here comes the part which is being used to count the number of odd elements. So what we are doing, we are checking uh, if the frequency of the element of the current element is even or not. Okay, if yes, like if the frequency is odd, we are adding 1. Okay, if no, then we are taking odd changes -1. So basically what we are doing, we are checking if after updating the frequency of the current element, will it hamper with the odd frequency which we are keeping a track of here. For example, in 233 we had, right, we were when we were at third. Okay, I'll tell, wait. Okay, so in this case, for example, if we were at this point, right, so at that point what we will get, odd change will be 1. Odd change will be 1. Why? Because the number of occurrence of 3 in the hash map was 1 only. Okay, but when we'll move to the next element, it should be what, 0 -1 basically. Why? Because we want to remove. So this is my odd value. Okay, let's go through it again. This is my number of odd values. With 2, when we were processing 2, it is marked as 1. Okay, when we jumped to the next element, which was 3, we updated it to 2. Okay, now this was 2 again. But when we see that, okay, 3 is occurring even number of times, we should remove -1 from here as well, right? So this is exactly what we're doing with that logic. So coming back to the code again, so this is what we are doing, and we are adding whatever we received in the odd change as in our odd number of frequency tracker. And to check if we have reached the root or node or the leaf node or not, this is the logic that the node should not have any left or any right subnode. Then we can say that, okay, we have reached the leaf node. And in that case, we can calculate the result. Like we can say if we want to add that path into the pseudo-palindromic path or not, right? So if my odd number of odd frequency element is less than or equal to 1, basically at most 1, then we would want to add that path in our result. Otherwise, we don't want it, right? Else, if we have not reached the leaf node yet, we will recursively call the same function, the DFS function, with the left and right subtree again. Okay. Next, this step is basically, when I explain you guys, we will be backtracking from each node to the previous node to check if we have anything on the other side as well. So this condition basically satisfies or basically resembles that situation. And at the end, we are returning the result. And over here, like this is the main function in which we are initializing the DFS with the root node. Okay. So this was the solution. Let's check out the test cases if it will be able to clear that or not. So as you can see, the test cases got clear. Let's submit it for further evaluation now. And the solution got accepted, and as you can see, like we are performing very well with the submissions. We have outperformed 95.56% of the submitted solutions. And yeah, this was the solution, guys. Thanks a ton for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.